We're looking at a very simple redox reaction. It's quite obvious that we have aluminum here oxidizing to aluminum plus 3, and copper is being reduced. It receives the electrons. But we can use the half reaction method to not only single out the oxidation and the reduction, but we can also balance reactions based on the half reaction method. So the first thing you want to do is always assign oxidation numbers to each element that's shown. So aluminum by itself is 0. Copper already has a charge. I'll write it above anyway. Aluminum has a charge on the product side, and copper here is 0. So that's step number 1. And now we single out the oxidation. We have aluminum solid, which produces aluminum ions and loses 3 electrons. And that would be the oxidation. Those electrons are received by the copper ion, and so the copper ion here, which has a +2 charge, can only take 2 of those 3 electrons. But we write the electrons on the left side, of course, to indicate that this is a reduction. And so this is the reduction. But the fact that we have uneven number of electrons helps us balance this reaction here, right? So we need to actually balance the electrons. We need to have an even number. So we do what we did when we make compounds. We just need 2 of those and 3 of those to make it 6 electrons each. And so when we do that and we bring it all back together, we end up with 2 aluminum metal and 3 copper ions and 6 electrons on the reactant side. Basically everything here pulled down, and on the product side we have 2 aluminum ions, we have 6 electrons, and 3 copper metals precipitating out here. So that's the overall redox reaction shown, and it's balanced now. Electrons drop out, so this is, in a way, it's the net ionic equation, or it is the overall equation. So this is when things are very simple, and of course if no counter ions are shown here, the counter ions are missing, we can use the electrons to balance this reaction. Now if you knew the counter ions, we would have been able to balance that without looking at the electrons, but it's worthwhile focusing on balancing the electrons, because if there are 6 electrons needed by copper, then we need to have 6 electrons generated. This and at the very end you might want to check if the atoms are all balanced as well as the charges. So the charge is +6 here, right? 3 times +2, and the charge is 2 times +3. The charges are balanced here, so we are good to go. Check mark. Moving on to something more complicated. So what if we have a more complicated redox reaction and other elements present? Okay, so we're still kind of missing some counter ions here, possibly, but let's just start by step number 1, putting oxidation numbers on each of the elements, and I mean each of the elements here, right? So chlorine is bound to itself, so it's 0. Iodine, we know, has a charge by it. Hydrogen in its compounds is always +1. This is not an exception. It's not a metal hydride, and so here it's not a peroxide either. It's just water, so oxygen is going to be -2 here. Chlorine here is -1, so we can see right away that chlorine was reduced. It gained an electron, went from 0 to -1. So might as well go ahead and write that down here. We have Cl2, which each chlorine needs 1 electron, so we need to add 2 electrons here, and we produce 2 chloride ions. So this is the reduction. Let's keep going. So iodate here, or IO3-, no matter what the name is. Oxygen is still -2. It's not by itself. It's not a peroxide, so it's -2. But based on that, we can determine the charge of iodine here, and so this would be +5. So there are 6 electrons that are ejected by that iodide. It goes from -1 to +5, so that's 6 electrons. That's our oxidation. And then hydrogen is just +1, so nothing happens with oxygen and hydrogen. The chemistry takes place between iodine and chlorine. Those are the elements that are being reduced and oxidized. So we have I minus going to IO3 minus and 6 electrons. That's the oxidation. So, so what happens when we have elements that are missing? Like we have the oxygen that's not balanced. We know we can balance these charges here. We have 2 electrons, so we simply need 3 of those. That we can do, but what about the oxygen? And then we have some hydrogen here. So what are the rules there? And so that's what we're looking at next, right? And so there are 6 rules, and we are going to go through all of them here, right? So we've already done step 1, assign oxidation states by determining the element oxidation and element reduced. Okay, so this is already balanced here, but never mind. We'll get to that at the end. Either way, we've done this already. Check. We did the half reactions. We did oxidation and reduction. We wrote those down. Check. And so then number 3 is balance the half reactions by mass. We did that. We have 2 chlorines on each side, and we have iodine, 1 iodine, but we are missing oxygen. So what do we do about oxygen? So once we've done that, we worry about hydrogen and oxygen. It says to add water where oxygen is needed. So oxygen is needed. We have I minus and going to IO3 minus and 6 electrons. So we need oxygen. So we need to add actually 3 water molecules. So we add 3 water molecules there. So the other one we don't have to worry about because it's already, let's go back to it, right? So that's already done, right? So we're only worried about the iodate here, the oxygen. We need it. So once you've done that, you add hydrogen where hydrogen is needed, right? So we've just added 6 hydrogens, and so I'll just keep going here and just add hydrogen here, but I'm going to need 6 of those. So this is C. I've done B and C all together. And then if the reaction is done in a base, neutralized with H plus or OH minus. Let's come back to that later. But so obviously if we have H plus here, this is going to be acidic. So what we're doing is we're balancing this in an acidic solution, and even if it's in a basic solution, you first do it in acid, and then at the very last step you can neutralize that, and we'll look at that later. Balance the half reactions. Balance that charge by adjusting the electrons. So we have to do that for the chlorine reaction, right? So we have Cl2 and 2 electrons going to 2Cl minus, and we have 6 electrons here, so we need to multiply this by 3, which will give us 6 electrons and then make 6 chloride ions. So number 5 would be add the 2 half reactions together. So I already wrote them out here for you, so all we have to do is add them together. So there are 3 water molecules and 1 iodide, 3 chlorines, and 6 electrons. That's everything on the reactant side. On the product side, we have IO3 minus and 6 electrons and 6 H plus and 6 chloride ions. And then finally you do your check. You count all of the elements. So we have, it's obviously balanced here, right? So we have 6 hydrogens on the reactant side. We have 6 hydrogens on the product side. So you kind of make a table, reactant and product side. Looking at oxygen, we have 3 oxygens on the left and 3 oxygens on the right. We have 1 iodine And then looking at chlorine, 2 times 3, that's 6 chlorines, and 6 chlorines on the product side. And so if you look at the charges, we have a -1 charge here. We have a -1 charge here, but we also have a +6 and the -6, so they cancel each other. So +6, -6, so the overall charge on the product side is also -1. So that's balanced as well. You are done with this in acidic solution. Now if this was done in basic solution, you would neutralize your acid with equivalents of hydroxide. So you would add 6 hydroxide ions to both sides. Okay, and so this should be here with the overall reaction, but it's kind of full, so I'm writing it up here. So we have 6 hydroxides here. What happens to this? It turns into 6 water molecules, right? But we also have water here on the left side, so 3 of those drop out. This is reduced to 3. So what this would be is, okay, I'll probably just want to write it out. So we have 6 hydroxide ions and I- and 3Cl. So I'm going to drop out the electrons to save myself some room here, because they do. And then on the product side we have IO3- and then 3 waters, and we still have the 6 chlorines. And so if I did that right, then you can do this cross-reference double check one more time. Okay, so here's everything clean. We did step 1 and 2, assigning oxidation numbers. Then we added water and hydrogens, color-coded here nicely. Here's just a little bit of a hint what to do when we are doing this in a basic solution. Balance the electrons, and then finally you bring them all together. Now this is done in an acidic solution, and so that is enough for this lecture. We're going to do one more half reaction method in an acidic, and then we're going to move on to electropotentials.